let's say we have a curve like that. This is our function, y is equal to f at x. So there's another method to estimating the area under the curve from A to B. So as the title suggests, we're going to use trapezoids. Okay, trapezoids. So here's my intervals. So let's cut up into those many pieces. And what we're going to do, we're going to connect the ends to end to form a trapezoid. Like this. Not a rectangle, but a trapezoid. And the reason why we would do this is because it gives us a better approximation. You can see, you can see how it's just visually how it's very close to the actual area. Okay, so recall that the trapezoids. Here's how you find the area of a trapezoid. Right? We need to know the length of the top and the bottom and the height. Okay. We have this kind of trapezoid right now. We have one side is straight, like this. Okay, so it's this. Half h times a plus b. That's the area of the trapezoid. So add top and bottom and times it by height and divide by 2. Well, in our case, it's actually flipped sideways, right? So we need to add this, right? And this. So if that's A, this right here will be A plus delta x. Okay, so this first area will be A plus f at A. Right? This height is f at A, right? And the second height will be f at A plus delta x. And then you have times that by height, and height is delta x. Divide that by 2. Okay, so this is the first rectangle. Okay, this is the first area, A1. Okay. So we need to add up n rectangles. What do you think so let's actually do the second one now. Just get a pattern. Again, delta x over 2. This time it's going to be f at A plus delta x plus f at A plus 2 times delta x. So continue this pattern, and let's say AI, some general term. Okay. So look, when it's 2, this back number is 2, and the first number is 1 less than 2. So it's going to be A plus I minus 1 delta x, I minus 1 delta x. And then A plus I delta x. Okay, so that was a mouthful. You might be thinking, wow, that's so much more complicated than left hand, right hand. Why would you do this?
No,
right.
I like this one.
But like in real life, right, you wouldn't be doing anything by hand. You would actually just punch this in and let the computer do it. And for the computer, it's all the same as soon as you punch it in. And this gives you a faster approximation, a better approximation.